NASA finds more traces of rivers and lakes on Mars August 8, 2019. And again, NASA's Curiosity spacecraft JEEP confirms that Mars had rivers and lakes. NASA finds more traces of rivers and lakes on Mars. Photo of clay deposits discovered by the Curiosity drill rig on the slopes of Mount Sharp in Gale Crater. Photo, NASA/JPL Caltech/MSSS analysis of giant clay deposits, discovered by the Curiosity rover in May, showed that the rivers and lakes of Mars not only gradually dried up but also periodically received water, flooding the surrounding corners of the Gale crater. NASA's Jet Propulsion Laboratory website wrote that the rocks in the analyzed region preserve the evolutionary history of the Martian lakes, which existed at the bottom of the Gale crater and were neither invariable nor static. Have shown that the lakes not only diminished and dried up gradually, but also experienced a tumultuous and complicated history. Their study will help us understand how Mars lost water, aid Valerie Fox of the California Institute of Technology. Until recently, scientists were unaware of any reliable traces of water on the red planet in the past or present. In March 2013, the Curiosity drill rover discovered the first traces of water in clay deposits by drilling a rock called John Klein in one of its first drilling fields. Giant Lake. Later, scientists found many other deposits of clay and other evidence of the ancient existence of water on Mars. Scientists now believe that the Gale crater, where the Curiosity rover is today, is a giant, dry lake, with bottom lake sediments covering its central part, Mount Sharp. Recent findings, as well as images of the Mars Odyssey spacecraft and the Mars Reconnaissance Orbiter (MRO), which indicate traces of phyllosilicates, clay minerals that testify to the chemical action of water, have prompted scientists to inquire how these clay deposits could have arisen. Climate models liquid water, if present on Mars, could have existed on its surface for very short periods of time for a few 100 million years, and unlikely, as climate models show, it would be capable of producing such large quantities of water. Clay. In early May this year, the Curiosity rover hit these deposits by drilling the region. The discovery led scientists to spend almost 2 months analyzing the area. Analysis of local clays as well as images of the area revealed several new and unexpected properties of the ancient Mars hydrosphere. Rock samples drilled by the rover in the area revealed the largest amounts of clay minerals found during the mission. The Curiosity detected equally high amounts of clay elsewhere in Mount Sharp, including areas where MRO did not detect clay. This has led scientists to wonder what is causing the orbit and surface results to differ. One idea is that stones are the key. Although individual pebbles are too small for MRO to see, they can appear collectively to the orbiter as a single sign of clay scattered across the area. Dust also settles more readily on smooth rocks than it does on pebbles. This same dust can obscure the signal seen from space. The pebbles were too small for Curiosity to drill, so the scientific team is looking for other clues to solve this puzzle. Scientists are now trying to find more clay deposits so that the rover can take samples and analyze the chemical composition in detail. These data will help scientists understand what the waters of Mars looked like and whether they could really sustain life, as already indicated by measurements in other regions of the Gale crater.